It has a core refractive index of 1.5. So remember this, analyze the data. If the step index fiber has a core refractive index of 1.5. So what you need to understand is what they have given is refractive index of the core N1, that is 1.5. Clear? Then a cladding of refractive index 1.48. A cladding of refractive index 1.48. So N2 is 1.48. Clear? Then a core diameter of 100 micrometer. So the core diameter is going to be 100 micrometers. Clear? So this is your third data. Now what they are asking is calculate that the fiber is kept in air. Calculate, assuming that the fiber is kept in air, find out numerical aperture of the fiber, NA. So what you need to find is NA first, then followed by angles alpha m, that is maximum acceptance angle, okay, then theta m, okay, incident angle, that is theta m, then phi c, that is critical angle, and then pulse broadening per unit length. So this is going to be the last thing of the parameter that is we are going to find is going to be different. Other than that, all the other terminologies, parameters have been discussed already. Clear? So the first thing what we are going to find is numerical aperture. So what we have is N1 and N2. So we can find NA easily. So NA is equal to square root of N1 square minus N2 square. Clear? So what they have substituted is the value for N1 and N2. Okay. So you can find the answer of NA easily. And we know that numerical aperture is related with alpha m, that is maximum acceptance angle. Correct? How? NA is equal to NA times sine alpha m. Okay. So we know that the refractive index of the air is going to be 1. So NA becomes 1 here. So follow this. Okay. I'm going to repeat it again. NA is equal to NA times sine alpha m is another terminology for numerical aperture, where NA is going to be 1 because it is refractive index of the air. So sine times alpha m, it is going to be present. So what we are going to find is alpha m simply. So from this formula, we can find alpha m, what is the value, correct? Because we found NA already. So by substituting the value of NA, we can find alpha m very simply. Clear? Okay. Now, what about theta m? To find theta m, I am going to make use of Snell's law. Okay. What we are going to make use of is Snell's law, where we are going to find theta m from that. So by using Snell's law, we are going to relate two consecutive parameters, that is NA and alpha m, to that of N1 and theta m. Clear? We are going to relate NA alpha m to that of N1 times theta m. How? Yeah, we know that N1 sine theta 1 is equal to N2 sine theta 2. We are going to replace N1 and theta 1 by what? NA and alpha m. Clear? So NA times sine alpha m is equal to N1 times sine theta m. Okay, and we know the value of NA times sine alpha m is nothing but what? It is going to be numerical aperture's value. So we are going to substitute the value of 0.244 here. And we know the value of N1 is given there as 1.5. So from this relation, we can find what? Theta m completely. So this is how you need to deal with the problem. Clear? Is there any doubts you have? Yes? Is that clear for everyone? Yes, no? Is the problem clear for you? So we have substituted the values simply to that of the what? Mathematical expressions. So we have discussed about Snell's law, we have discussed about critical angle phi c, we have discussed about what then numerical aperture, the different forms of numerical aperture. We are going to make use of all these formulas to find out the values. Clear? Okay. Now, what we are going to see next is about the ray propagation in graded index fibers. So this will be kind of more theoretical. So what I need to do here is, so we have completed step index fibers and the mathematical expressions related to step index fibers. So we will keep it that way. For the next class, we will discuss about the parameters, mathematical expressions related to graded index fibers. Okay. So because it might confuse you. When I graded index fibers உடைய formulas சொல்லி கொடுத்தனா the step index fibers ஒரு சின்ன confusion வரும் உங்களுக்கு. இப்போ இன்னைக்கு step index fiber உடைய formulas எல்லாம் ஓரளவுக்கு படிச்சிருப்பீங்க. Mathematical expression அதை வச்சு எப்படி problem solve பண்ணணும்னு தெரிஞ்சிருக்கும். So what I'm going to do is we are going to move forward where we are going to discuss about the wave propagation in planar waveguides. Clear? So இது வந்து ஒரு general concept மாதிரி உங்களுக்கு ஒரு விஷயம் சொல்லிடுறேன் because it is too much lengthy. Okay. இது வரைக்கும் என்ன பார்த்திருக்கோம் அப்படின்னு கேட்டீங்கன்னா we have considered a light to be rays. We have discussed with respect to ray optics. Okay, we haven't considered about electromagnetic theory to that of the light. Okay, so இப்போ இது வரைக்கும் என்ன டிஸ்கஸ் பண்ணியிருக்கோம் லைட்டை வந்து ஜஸ்ட் ரே ஆப்டிக்ஸ் பேஸ் பண்ணி அதோடைய மேத்தமெட்டிக்கல் எக்ஸ்பிரஷன்ஸ் எப்படி இருக்கும், அதோடைய லைட் டிராவல் நேச்சர் எப்படி இருக்கும், அது ஒரு மீடியம்ல இருந்து இன்னொரு மீடியம் கிராஸ் ஆகும்போது எப்படி நடக்கும், என்ன ரிஃப்ளெக்ஷன் நடக்குமா, ரீஃப்ராக்ஷன் நடக்குமா, என்ன ஆங்கிள் ரிஃப்ளெக்ஷன் நடக்கும், எப்படி ரீஃப்ராக்ஷன் நடக்கும், இதுதான் நம்ம இது வரைக்கும் பார்த்துருக்கோம் இல்லையா. Since light ray is also an electromagnetic wave, we need to include this electromagnetic theory to that of light. Clear? So இதுல சில basics இருக்கு. So when we consider the light rays to be of electromagnetic wave, okay, so we need to consider four equations of Maxwell's. So del cross E is equal to minus that you can see in the window here. Okay, so four expressions are required. Del cross E is equal to minus dou B by dou T. The second expression is del cross H is equal to J plus dou D by dou T. Del dot D is equal to rho. Del dot B is equal to 0. So what are all these four equations that correspond to? So where the first expression we are going to deal with electric field. Okay, so E represents your electric field with respect to what? Magnetic flux density. Okay, B. Okay, that is how it is being related. Okay, so இந்த நாலு விஷயம் மட்டும் தெரிஞ்சுக்கோங்க. ஒரு எலக்ட்ரோமேக்னெட்டிக் வேவ்னு எடுத்துக்கிட்டோம்னா அந்த லைட் எலக்ட்ரோமேக்னெட்டிக் வேவா கன்சிடர் பண்ணிக்கும் போது அந்த பிளேன் டிரான்ஸ் எலக்ட்ரோமேக்னெட்டிக் வேவோட அப்பியரன்ஸ் எப்படி இருக்கும்னா that is before you. இந்த விண்டோல காமிக்கிறேன் இல்லையா, that is how it will be. So அதோடைய ரெப்ரசன்டேஷனுக்கு four Maxwell equations will be used. So இப்போ பாத்தீங்கன்னா we can see a sinusoidal kind of wave that is originating from x-axis and moves towards the z-axis, correct? So we have a tri-axis line x, y and z. Okay, இதுல E என்ற வேல்யூ வந்து எப்படி சேஞ்ச் ஆகுதுன்னு பாத்தீங்கன்னா with respect to x but it travels over z. Clear? Similarly அதே மாதிரி அது பெர்பெண்டிகுலரா பாத்தீங்கன்னா h இருக்கும். Okay, that is your magnetic flux value h. And the magnetic flux value எப்படி சேஞ்ச் ஆகுதுன்னு பாத்தீங்கன்னா with respect to y axis and it is going to travel in a way perpendicular to that of the E. Okay, and again it is going to travel over z. So what you need to understand is light contains electromagnetic wave spectrum. அப்படின்னு எடுத்துக்கிட்டோம்னா we need to consider both electrical theory, electric wave propagation and magnetic flux wave propagation. Clear? So both will be perpendicular. Electric and magnetic field will be perpendicular. So taking that into a concern, we can represent it as like this. Okay, இப்போ நீங்க ஒரு விஷயம் புரிஞ்சுக்கணும், இதுக்கு முன்னாடி பார்த்தது எல்லாமே ray optics. It is about ray optics, how the light travels. We are going to take it as simply as a ray. As a ray has been considered, how it will travel from one medium to another. இப்படி தான் பார்த்தோம். By இப்போ என்ன பார்க்க போறோம் அப்படின்னு கேட்டீங்கன்னா, if we consider light as an electromagnetic thing, okay, if it considered as an electromagnetic wave, how the wave propagation it will be? It will have electric field and magnetic field perpendicular to each other. Okay, both will travel to a particular axis. Clear? So we have this XYZ plane where the electric field is going to travel like this, whereas the magnetic field density is going to travel like this. So we are going to represent it in terms of Maxwell equations where del cross E is equal to minus dou B by dou T. Clear? And similarly del cross H is equal to J plus dou D by dou T. Now E is nothing but what? Electric field. Clear? Where B is the magnetic field vector in terms of ampere per meter. So what you need to understand is electric field and magnetic field are related to each other. So if I want to describe electric field, it will be in terms of magnetic field. So if I want to describe about magnetic field vector, again it will correspond to electrical parameters. Okay, it is about current density, it is about electron density and so on. Clear? So del cross E is equal to minus dou B by dou T, and again del cross H, the magnetic field vector, is given by J plus dou D by dou T. Okay, so J is nothing but your current density. Clear? So D is nothing but your electric displacement, coulombs per meter square. Okay, this is how you need to understand as an electromagnetic wave when we go for light. Okay, so இதுக்கப்புறம் இன்னும் நிறைய விஷயங்கள் இருக்கு, இப்போதைக்கு இது மட்டும் தெரிஞ்சுக்கோங்க. So a light can be considered with respect to, we can deal with respect to ray optics, we can deal with respect to an electromagnetic wave propagation theory. Okay, we can consider both. Okay, both should be considered. Clear? So next what we are going to see is next thing what we are going to see for today is about okay, is it visible for everyone? I am presenting a window again, so kindly tell me if it is not visible. I will again present it to you. Okay, yes, it is visible. So now what we are going to see is, so I will brush up the topics what we have seen so far again. So we have seen about the construction of optical fiber. Okay, we have dealt about the basic laws behind the optical fibers working. We dealt about critical angle, we dealt about total internal reflection, we dealt about Snell's law, we dealt about acceptance angle, numerical aperture, etc. Okay, now what you need to know is how the light travels inside a step index fiber, how a light travels in a multimode index fiber, how a light travels inside a graded index fiber. That you need to understand. So I have put you a window where you can see the travel of light in all these three fibers, how it will be. So is it visible for everyone? Is it visible? எல்லாருக்கும் தெரியுதுங்களா? ஸோ இப்போ ஒரு டயக்ராம் ஒன்று இருக்கு, மூணு கன்சிக்யூட்டிவ் டயக்ராம் இருக்கும், தெரியுதுங்களா? இஸ் இட் விசிபிள்? எஸ், எஸ், நோ, ஓகே, தேங்க்யூ. So in a step index fiber, look how the light rays travel. So இது மூணுத்திலுமே காமனா இருக்கக்கூடிய ஒரு விஷயம் என்னன்னு கவனிச்சீங்கன்னா, the light ray which travels through the axis doesn't undergo any reflection, refraction at all. It travels simply in a straight line manner. Clear? So in all the three diagrams, you can find the light ray which travels through the axis travels in a straight line. Okay. Apart from that, the other light rays with different acceptance angles or different incident angles travels how? That is what we are going to see next. So in single mode fiber or single mode fiber, what you can understand is that it will have the light ray to travel in a straight line. Very simple. So we are going to cancel that. So we are going to see now step index and graded index fiber alone. So என்ன புரிஞ்சுக்கிட்டு இருப்பீங்க, single mode fiber light ray is going to travel in a very straight line through the axis. So I'm going to keep that apart. Now in a step index fiber, when you look at it, you can see there is number of total internal reflections that is taking place. Correct? Likewise, in graded index fiber also you can find multiple number of total internal reflections. Correct? So what is the understanding of these diagrams? இதுல இருந்து என்ன புரிஞ்சிக்க முடியும்? இப்போ இருக்கக்கூடிய ரிஃப்ளெக்ஷன்ஸ் ரெண்டுத்துலயுமே நடக்குது, பட் அதோடைய நேச்சர் பாருங்க, அதோடைய எலக்ட்ரான் வேவ் நேச்சர் பாருங்க சேஞ்ச் ஆயிருக்கும். ஓகே, அந்த வேவோடைய பேட்டர்ன் சேஞ்ச் ஆயிருக்கும். ஸோ என்ன புரிஞ்சிக்க முடியுது இதுல இருந்து? வாட் யூ அண்டர்ஸ்டாண்ட் ஃப்ரம் திஸ்? ஸோ இன் step index fiber, we can find dispersion of light that occurs after it is being transmitted or at the end point. Okay, so இதுல பாத்தீங்கன்னா ஒரு காமன், there is no common point where meeting up of light rays is taking place in between. Okay, whereas in a graded index fiber we can find number of refocusing points in between the travel. Okay, நீங்க புரிஞ்சுக்க வேண்டிய விஷயம் ஒண்ணே ஒண்ணுதான். In graded index fiber we will find what? Refocusing points in between the travel. Okay, whereas in a step index fiber we won't find refocusing points at all. So what happens is, at the end of the optical fiber we find much dispersion in case of step index, whereas in a graded index fiber we won't find these dispersion phenomena. We will find focused of light phenomena. Clear? So focused light will be obtained at the end of the graded index fiber, whereas in a step index fiber this is quite not possible. Clear? Because all we have is dispersion. Okay, is that clear for everyone? Any doubts you have? So the light propagation புரிஞ்சிருக்கும்னு நினைக்கிறேன். Yes or no? புரிஞ்சுதா? Yes? No? Answer. I need answer in chat box. புரிஞ்சுதா இல்லையா? Yes, no? So none is listening. யாரும் கவனிக்கல போ. அப்படி எடுத்துக்கலாமா? ஓகே, தேங்க்யூ. சொன்ன விஷயம் புரிஞ்சுதுங்களாப்பா எல்லாருக்கும்? என்ன சொன்னு புரிஞ்சுதா? இந்த கான்செப்ட் புரிஞ்சிருக்கும்னு நினைக்கிறேன். ரொம்ப சிம்பிள் தான். இந்த லைட் வேவ் ப்ரொபகேஷன் எப்படி இருக்கும்? ஸ்டெப் இண்டெக்ஸ் ஃபைபரா இருந்தா எப்படி டிராவல் ஆகும் லைட் வேவ், அதுவே கிரேட்டட் இண்டெக்ஸ் ஃபைபரா இருந்தா என்ன ஆகும்? ஒரே விஷயம் தான். ரீஃபோக்கசிங்ன்ற ஒரு விஷயம் எதுல நடக்காதுன்னு கேட்டீங்கன்னா ஸ்டெப் இண்டெக்ஸ் ஃபைபர்ல கம்ப்ளீட்டா இருக்காது. ஆனா எங்க இருக்கும்னு கேட்டீங்கன்னா கிரேட்டட் இண்டெக்ஸ் ஃபைபர்ல யூ வில் ஃபைண்ட் ரீஃபோக்கசிங். அதுக்கு காரணம் வெரி சிம்பிள். The value of the refractive index is going to change in a gradual manner for graded index fiber, whereas in a step index fiber it is not a phenomena. Step index fiber la gradually change agudhu. It is going to have a sudden change. Okay, clear? Yes. Now the next thing what we are going to see is classification based upon the material. So in the previous classes I told you the classification based upon the modes of light travel and the refractive index profile, correct? So ரெண்டு classification முன்னாடி சொல்லிருக்கோம். Based upon what? Modes of light travel and refractive index. So based upon the mode of light travel we can say single mode and multi-mode. And based upon refractive index we can say step index and graded index, correct? Step index and graded index. Clear? Now there is one more classification. It is going to be based upon the kind of material we use. So it is upon two types. One is going to be glass and one is going to be plastic fiber. Okay, one is going to be glass and one is going to be plastic fiber. So comparatively, which is better when we go for glass or plastic fiber, which has greater transmission capability and less attenuation, less losses? So absolutely we know that glass is the only thing that exceeds the limit, okay, that can be used for what? Optical fiber. And why we need to have a plastic fiber then? So plastic fiber when we compare with the glass has certain advantages. Okay, these plastics have certain advantages. That is what we can say is a manufacturing easiness in the manufacturing. Okay, and the size and weight of the plastic when compared to that of the glass, and the flexibility, it all matters with that of the plastic material. Clear? So when we go for glass, what kind of core they use? What kind of cladding they use? That is what we are going to see next. So you can see it in the window where glass fibers of one kind is going to use a core as simply silicon dioxide, another kind is going to make use of germanium and silicon dioxide together. Okay, and cladding is going to be again a P2O3 SiO2 combination, and the other kind it is going to be SiO2 alone. So what you need to understand is, if I have core as a kind of one material, cladding will be having a different composition. Okay, so ஏன் இந்த மாதிரி ஒரு different composition கொண்டு வரணும்? core ஒரு kind யூஸ் பண்ணும்போது cladding அதே kind யூஸ் பண்ணலாம் இல்லையா? Why to have a different composition? So we are trying to achieve a different refractive index. Okay, நமக்கு நல்லா புரிஞ்ச ஒரு விஷயம் என்னன்னா, refractive index உடைய வேல்யூ வந்து சேஞ்ச் ஆச்சுன்னா மட்டும்தான் ரெண்டு மீடியம்ல என்ன நடக்கும்? Total internal reflection நடக்கும். What will happen? Total internal reflection will take place. So to achieve that, to achieve a possible total internal reflections, we need core and cladding of what? A different composition slightly to achieve a different refractive index value. So for that purposes, we have examples here. So for the first kind, if I use core as SiO2, the cladding will be P2O3 SiO2 layer. Okay, so that makes a different refractive index for the cladding. So if I use core to be germanium oxide, or that is GeO2 SiO2 combination, then I will go for what? Cladding with the SiO2 layer, simply SiO2 layer. So this creates a change in refractive index with respect to core and cladding. Clear? So now coming to plastic fibers. So in plastic fibers, we use polymethyl methacrylate and copolymers. Clear? So the core, if it is being polymethyl methacrylate, the cladding will be copolymer. If the core is going to be polystyrene, then the cladding will be methyl methacrylate simply. It is not going to be a polymethyl, it is going to be simply a methyl methacrylate. Okay, again the same condition prevails. We are going to achieve a different refractive index with respect to core and what? Cladding. So that is the idea behind. Am I clear? Okay, so this is your classification based upon the materials. So the different types of fibers based upon material is going to be glass and plastic. Different types of fibers with respect to number of modes is going to be single and multi-mode. With respect to refractive index profile, we can say it has step index and graded index fiber. Okay, so this completes your classification. So what I'm going to make you see is about the structure. Okay, so we are going to have a comparison structure of a step index and multimode index. So the first diagram what you see here is going to be a step index profile. Step index profile of a fiber. If we go for multimode fibers, it will be like this. You will have the diameter of the core to be slightly higher. Okay, and compared to that of the step index mode. Now, the next thing what we are going to study is about the fiber characteristics. So the characteristics associated with the fiber. Okay, so இப்போ இது வரைக்கும் சொன்ன விஷயம் எல்லாருக்கும் புரிஞ்சுதா? Yes? Yes or no? Okay, சரி. புரியலனா அந்த இன்ஸ்டன்ட்லே chat boxல போட்டுங்க, நான் மறுபடியும் கூட எடுத்துறேன். So இப்போ எலக்ட்ரோமேக்னெட்டிக் பேஸ்ட் தியரி வந்து நம்ம கம்ப்ளீட்டா அனலைஸ் பண்ணல, ஜஸ்ட் ஒரு இன்ட்ரோடக்ஷன் தான் கொடுத்துருக்கேன். ஏன்னா உங்களுக்கு கன்ஃபியூஷன் வரும். இப்போதைக்கு ரே ஆப்டிக்ஸ் மட்டும் நல்லா கம்ப்ளீட்டா தெரிஞ்சுக்கிட்டு இருப்பீங்க. ஆஃப்டர் ரே ஆப்டிக்ஸ் we went for light to be considered as electromagnetic wave propagation. அதுல சின்னதா ஒரு பேசிக் மட்டும் கொடுத்துருக்கேன். ஓகே, அப்புறம் என்ன டிஸ்கஸ் பண்ணியிருக்கோம் இன்னைக்கு? ஒரு ப்ராப்ளம் டிஸ்கஸ் பண்ணியிருக்கோம். அந்த ப்ராப்ளம் இஸ் ரிலேட்டட் டு ஸ்டெப் இண்டெக்ஸ் கண்டிஷன்ஸ். ஸ்டெப் இண்டெக்ஸ் கண்டிஷன்ல இருக்கக்கூடிய மேத்தமெட்டிக்கல் எக்ஸ்பிரஷன்ஸ். Okay, similarly we can go for what? Again graded index. As the graded index உடைய mathematical expression கொடுத்தா it will be much confusing. So இன்னைக்கு அந்த ப்ராப்ளம் மட்டும் டிஸ்கஸ் பண்ணுவோம். The next class, if possible, we will discuss about graded index fiber mathematical expressions and problems associated. So if at all, if it has been asked in your syllabus, we will discuss about it. Okay. Now the next thing what we are going to study is about the fiber characteristics. Okay, the characteristics associated with the fiber. So the fiber characteristics is classified into two. One is going to be called as mechanical characteristics, and the second is going to be called as attenuation characteristics. Okay, one is mechanical and the second one is going to be, second fiber characteristic is going to be about attenuation. So when we think about mechanical characteristics, Okay. So you see here, in mechanical characteristics, we are going to discuss about three. One is going to be strength. Absolutely, when we discuss about mechanical characteristics, what will come in your mind is will be strength of the optical fiber. The second is going to be static fatigue of the fiber, the static fatigue nature of the fiber. The third is going to be dynamic fatigue nature of the fiber. So we are going to understand what is static fatigue and what you are going to be called as dynamic fatigue. Okay. Before that, you need to understand about strength. Okay. So the strength of the fiber, it is going to be dependent upon the constant atoms of the glass that is going to govern. So என்ன புரிஞ்சுக்க போறோம்னா the strength of the mechanical nature of the fiber வந்து எதை டிபெண்ட் பண்ணி இருக்க போகுது அப்படின்னு கேட்டீங்கன்னா, if we use glass, it is going to depend upon the atoms of silica atoms உடைய நேச்சரை டிபெண்ட் பண்ணி இருக்க போகுது. அந்த சிலிக்கா ஆட்டம்ஸ் உடைய கொஹசிவ் பாண்ட் ஸ்ட்ரென்த் டிபெண்ட் பண்ணி என்ன இருக்க போகுது, the mechanical strength இருக்க போகுது. ஸோ அதோடைய மேக்ஸிமம் டென்சைல் ஸ்ட்ரென்த் எவ்வளவு under fiber characteristics? Mechanical characteristics deals with strength, static fatigue, and dynamic fatigue. Clear? And when we go for transmission characteristics, the first thing will be attenuation. This attenuation will depend upon the type of material we use, the type of fiber we use. Clear? And the second one is going to be about absorption losses. So when we go for absorption losses, it does correspond to what? Intrinsic and extrinsic. Intrinsic corresponds to what? Basic fiber material properties. அப்படின்னா என்ன சார் சொல்ல வரீங்க? இன்ட்ரின்சிக்னா என்ன? இப்போ இந்த ஃபைபர் மெட்டீரியல் இருக்கக்கூடிய அட்டாமிக் ஸ்ட்ரக்சர், அதுல இருக்கக்கூடிய இம்பர்ஃபெக்ஷன், ஆர் அந்த மாலிகுல் கூட சேர்ந்து இருக்கக்கூடிய இம்பர்ஃபெக்ஷன். ஒரு மாலிகுல் எல்லாம் சேர்ந்து ஒரு ஃபார்மேஷன் கொண்டு வரும்போது தான் அது ஒரு ஸ்ட்ரக்சரா ஃபார்ம் ஆகுது. அந்த மாதிரி இருக்கும்போது ஒரு இன்னோபிஜினிட்டி ஆர் அந்த ஸ்ட்ரக்சர்ல இருக்கக்கூடிய some misalignment will correspond to what? Intrinsic absorption. Okay. Whereas extrinsic absorption is completely corresponding to what? Impurities. இதுல இன்னொன்னு ஒரு விஷயம் சொல்ல மறந்துட்டாங்க. When we correspond to extrinsic absorption during manufacturing of glass optical fibers, we will make use of what? Iron, nickel, chromium, etc. Because the components that are used for manufacturing will be made use of what? Iron, nickel, chromium, etc. Right. So these iron, nickel, chromium atoms will impose some impurities over the glass fiber. Okay. That will also correspond to what? Extrinsic absorption. Okay. Is that clear for everyone? So under absorption losses, you need to understand about intrinsic absorption. It is due to what? It is completely due to about the fiber material properties, basic fiber material properties. When we go for extrinsic absorption, it is going to be about the impurities that is going to be introduced during manufacturing, during creation of difference in refractive index values. Clear? So it is about the impurities such as iron, nickel, chromium, OH minus ions, etc. during fabrication. Is that clear for everyone? Hope I made this clear for you. Yes? Okay, we will proceed further. Next thing what we are going to see is about the scattering losses that may occur in your optical fiber. Okay, so when we correspond to scattering losses, we need to understand about different scattering capabilities or scattering principles associated. Okay, we know about Rayleigh scattering. We have studied previously in your 12th standard or in your schooling. You might have crossed about this principle of Rayleigh scattering. And likewise, there is one thing called Mie scattering, Mie scattering. Okay. Similarly, there is one more scattering loss that is called as non-linear scattering. We call that as Brillouin, Brillouin, Brillouin scattering losses. These correspond to non-linear, okay? Whereas Rayleigh and Mie scattering is due to correspond to what? Linear scattering losses. Is that clear for everyone? Okay. So what we have studied so far is about the fiber characteristics, and we have studied about the absorption losses, the basics of absorption losses. Okay. We are moving forward with scattering losses next. Okay. That we will discuss in the next class. So for today's problem, we have discussed with respect to single mode fiber alone. Okay. In the forthcoming classes, we will discuss more problem. Okay. So I'm going to quit my session for today. Okay. The next subject staff will join you shortly. Clear?
Hello. Sadeesh, வந்துட்டேன்.
வந்துட்டீங்களா சார்? Thank you.
வந்தாச்சு. ஓகே சதீஷ்.
ஒரே நிமிஷம் டவுட்ஸ் இருக்கான்னு மட்டும் கேட்டுக்கிறேன்.
கேக்குது.
Any doubts you have?